most people have seen complex numbers before. Remember, these are the ones where you have this mysterious letter I, which is equal to the square root of -1, right? Those things that aren't real, they're imaginary. Well, in this problem, what we're doing is we're taking two complex numbers. One's W, one is Z, and we're just doing some arithmetic on them. So in this first example, I have 2 times W. Well, you just multiply each part of W times 2. So this becomes 6 plus 2i. All right, so if you treat them like a polynomial, you will get through this problem just fine. Now, a little more detail while you're here. This thing says a rectangular form as a plus bi. I want to emphasize something here that I think is pretty important. A is what's called the real part, and b, right here, and I'm talking about b, so a equals the real part, b equals the imaginary part. And every number has both of these parts. Sometimes the part is 0. Sometimes, like a number like 7. 7 has no imaginary part. It's just a real number. But we would say b equals 0 and a equals 7 for the complex number 7. So you can think about these numbers that way. And then for the rest of these problems, all you're doing is you're multiplying something by that complex number. So, for example, I times z. Well, it's going to be 5i plus 2i squared, right? Except instead of I squared, we're going to write these as simplified answers. So if you remember, I squared is -1, so this is going to become, instead of plus 2i squared, it's going to be minus 2i, and so on and so on and so on. Just treat them like polynomials, except they have a real part and an imaginary part.